And the last thing left is to find the non-repetitive surge current. The value of the maximum value of the current that will flow during the very first cycle when the capacitor reaches from its bare minimum value of 0 volt to its peak value of 10 volt. The current corresponding to it will be known as the surge value of the current. And we know that the charges delta Q is equal to C delta V, and we already know the value of the capacitance, now 2340 microfarad, and the value of current is, and the voltage delta V in this case is 10 because the voltage is varying from 0 to its maximum value 10 volt, whereas in the next cycles the capacitor will be varying between these values 10 volt to 990 volt, and then once again it will charge up to 10 volt, and it will then discharge from 10 volt to 990 volt, and so on. So the current corresponding to these variations from 10 volt to 990 volt is known as peak repetitive current, but the non-repetitive value of the current that will only come during the first cycle when the capacitor is initially completely discharged and will reach from its zero value to the maximum value will be known as non-repetitive surge current. So the charges that will be accumulated during this time period will be this 2340 into 10 volt, and if I want to find the current corresponding to it, this is Q by T. The product of these two will be the Q, and T is 5 millisecond, this, because it is reaching to its peak value during the quarter cycle. Hence no, that's it. So you can see that the value of current is 472 ampere, which is huge, and the diodes that I have selected for this purpose should be capable of withstanding at least this much surge current, 472 ampere. So even if I have considered all the other values and have not considered this I surge value in the design of my rectifiers, the result will be this will result into the failure of our circuit. So that's it for today's lecture. Thank you very much.